You join me today after the successful completion of the first test of the CNC control equipment and stepper motors. In the bottom right corner of the screen, we see this stepper motor, which is wired to the X-axis of the Arduino stepper motor shield. It's wired to the X-axis. I'm controlling these steps by using a universal code platform application on my laptop PC. In the previous video I showed the interface for this application and how we could use this interface to stop and start and control the 3 axes of my home build CNC machine. Let's have a little look around the parts on this test bed. So we have the Arduino, which is mounted below a stepper motor shield with 3 channels, X, Y and Z, one for each axis, which is X, possibly Y and possibly Z. A 24 volt power supply, set at 23.9, but we won't split hairs today. That's supplying power to the stepper motor shield, which is the controller board, which in itself is attached to the Arduino Uno. Powered at present by a USB cable from the laptop and cooled between the boards by this fan and this fan at the rear. When the whole system is in operation on the CNC machine, this fan will rest across the top here, blowing down onto these stepper motor drivers, keeping them cool and avoiding thermal stoppages. When they overheat, they stop. So the key is stop them from overheating any way possible. These stepper motors, 1.8 Newton meters of torque at 24 volts. When they're under load on a CNC machine and they're taking a heavy cut and they're drawing the maximum amperage, that work is transformed into heat within the stepper motor driver, and if that heat isn't dissipated, eventually the driver decides it's had enough and shuts down. So obviously you don't want that to happen in the middle of a CNC path job. The fans in this instance are powered by a 7.2 rechargeable battery that I use for many of my radio control projects. Find it a great source of power. The power supply for the CNC, this is a variable power supply up to 30 volts and up to 10 amps. It's a new unit for me. It's working okay at present, but time will tell how reliable it is. The stepper motors, nema 23s. Just as a matter of interest, the length of the body of a stepper motor governs the amount of torque, which presumably is because the bigger or longer the body, the bigger or longer the magnets within inside, and so the more torque they can create. As I said at the beginning, these are nema 23s, 1.8 Newton meters of torque at 24 volts. Zooming in on that one, clicking on the x-axis, massive achievement. Jogging it as you would when you're positioning a tool at the beginning of a job, and in reverse just as easily. And I see that on the board we've got a green LED that flashes to show that that stepper driver is doing its thing. Super. So that concludes today's first test of the CNC control assembly and stepper motors. Thanks for watching.